So the next problem, we have a state table, and we are given state assignments. Sometimes you're given state assignments, sometimes you're not. And you are supposed to come up with the state assigned table, so we want to put everything in terms of these zeros and ones. So this one's going to take a while. We also are going to derive minimal Boolean out expressions for the next state. We could draw a circuit from this once we have it done, but we're not going to. Notice we have 3 states here. That's not a power of 2. That means that we need to be careful that we're going to have some don't cares somewhere. We're going to have some unassigned stuff going on. So we'll start by changing this to this. So output Z, A, B, C. This will be the next state, and this will be W equals 0, W equals 1. This will be the present state, and I am going to call the present state, I'll call that lowercase y1, lowercase y2, and the next state I will call those uppercase y1 and y2. So uppercase y1, uppercase y2, uppercase y1, uppercase y2. And we are told to use these. If you're not told, you're allowed to do it however you want. So 0, 0 for A, 1, 1 for B, 1, 0 for C, and that leaves unassigned 0, 1. So those are going to be don't cares. So I'll just go ahead and fill those in. Those are don't cares. And output 1, 1, 0. And we have, all we're doing at this point is we are translating these letters to how we have defined them in terms of these 2-bit values. So C is 1, 0. So this is 1, 0. A is 0, 0. 0, 0. B is 1, 1. 1, 1, and 1, 1. Okay, so now we want to come up with simplified Boolean expressions. So we'll use K-maps for this. So I'll start by coming up with my K-map for y1. And y1 depends on the present state, which is lowercase y1, y2, and input w. So w0, w1, 0, 0, 0, 1, 1, 1, 1, 0. Now I'm just looking at y1. That means I'm just looking at the first column in my table here that's representing y1. Notice sometimes that we put the most significant bit at the beginning and sometimes we put it at the end. Probably would have been more kosher for me to write this as y2, y1, or even as y1, y0, but there's not a rule, and so you'll see it every which way. Okay, so I know when the present state is 0, 1, I have don't cares, so I'll just go ahead and fill those in. And this block right here, that goes with W equals 0. W equals 0 is my first row of this table. So when W is 0 and my present state is 0, 0, y1 is 1. When W is 0 and my present state is 1, 1, y1 is 0. And when W is 0 and my present state is 1, 0, y1 is 1. So now I'll go to my second column over here, and that corresponds to w being 1. When the present state is 0, 0, y1 is 0. When it's 1, 1, it's 1. And when it is 1, 0, it is also 1. And so my minimal cover here looks to be this. So I have y1 equals, this top circle has y2 equal to 0, so that's y2 bar, and w equal to 0, so that's w bar, plus, and this bottom row, I have w equal to 1, and I have y1 equal to 1. So that is my expression, and this would correspond to a flip-flop. So this y1, so if I were making a circuit, that would be a flip-flop. So that would be a D flip-flop. And now let's do y2. This will be y2. And I have little y1, little y2, and w, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. I know I have don't cares here. So now I'm looking at my second column for when w is 0. I have 0 when the present state is 0, 0. I have 0 when the present state is 1, 1. And I have 1 when the present state is 1, 0. In the second column, which corresponds to w equals 1, I have 0 for 0, 0, and 1s for the other two. So that would get me this, would cover that. So that would tell me that y2 can equal, this last column has y1 equal to 1 and y2 equal to 0, so y1, y2 bar, or in this bottom row that has w equal to 1, and if I look at these two columns, y1 equal to 1. And then lastly, our output. And our output, notice this is a Moore machine, and I know it's a Moore machine because my output does not depend on my input. If my output depended on my input, I would have two columns here. I would have a w equals 0 column and a w equals 1 column, but I don't. So my output depends just on my state, so just on y1, y2, so 0, 1, 0, 1, and I had a don't care here, and I have 1s for 0, 0, and 1, 1. And that's a 0. So I can get these two. So z equals y1 bar or y2. And this was not part of the problem, but I just realized I don't have one where I would then go on and show what to do with this if you had to draw flip-flops. So I'll just go ahead and show you. So we have two flip-flops. So I'll call them 1 and 2. And we had our one input W. And Y1 was, so if we look at Y1 we said was Y2 bar, W bar, plus WY1. Okay, so here's Q and Q bar, Q and Q bar. I actually used the Q bar from the D flip-flops rather than a not, but you can also use a not. So this is an AND of W bar and Y2 bar, and that is ORed with the AND of W and Y1, and that's my input into Y1, and Y2 was over here. Y2 is Y1 ANDed with Y2 bar. So here's Y1 ANDed with Y2 bar, and that's ORed with W and Y1. I am the messiest. W and Y1, so that's Y1, and these are ORed together, and that's our Y2, and our Z is Y1 bar or Y2, so Y1 bar or Y2, and that's Z. I know that's not legible. That's just... Questions?